Welcome to Brain Vision.
Okay, so we just want to calculate the work done by friction on a crate of fruits sitting on a ramp. All right, so let's say this is our ramp. We are told that this ramp is inclined at an angle of 36.9 degrees below the horizontal. Now, let's come to the foot of the ramp. The foot of the ramp will make similar angle, 36.9 degrees. All right. So at the end of the day, this is how our diagram should look like. Okay. This is more easier to work with. So we have our crate with fruits in here situated here. Now we are told that this ramp is 8 meters long. And then this crate is situated above the ground at a height h. Now, considering the energy of the crate of fruits, it possesses potential energy at the top. Now, this crate slides down the ramp from an initial velocity of 0, in other words, it's at rest, and then accelerates down or moves down the ramp and attains a final velocity of 2.5. All right. So the potential energy will be converted to kinetic energy and then some amount of heat loss. Now, the heat loss is the work done by friction. Heat loss is the work done by friction. Now, we know potential energy is given as mgh, and then kinetic energy is given as half m, let me put it into bracket, m into bracket v minus u all squared. Okay, plus our work function or heat loss. Oh, sorry, work function, sorry, work done by friction. I beg your pardon. Work done by friction. All right, now the mass of the crate is 35 kilograms. We also know that gravity is 9.8, but we don't know for the height. We don't know for the height. Height, we don't know. But we can calculate height from the diagram up here. We can calculate the height from the diagram up here. So I'm going to redraw the diagram. So let's say this is my diagram again. So this is the height. This is the height where the crate is situated. And then the angle here is at 36.9 degrees. Now, the ramp is 8 meters long. So to calculate for the height, we'll say sine theta is equal to the height divided by the length of the ramp. Let's say L. Let me represent that with L, the length of the ramp, which is the 8 meters. All right. So we say that sine 36.9 is equal to h divided by the length of the ramp, which is what? 8. All right. So we can say that h is equal to 8 sine 36.9. All right. So this is what we're going to use inside our equation for the height. So going back to our equation, we have the mass of the crate to be 35 kilograms multiplied by gravity 9.8 times the height, which is 8 sine 36.9, which is equal to the kinetic energy half times the mass of the crate 35 times into bracket the final velocity of the crate was 2.5 and the initial was 0 because it started from rest, and all this squared. Good. Now when you do that, sorry, I forgot one thing, plus the work done by the friction. All right, I beg your pardon. All right, so let's go on. So when we calculate that, we'll get 1647.6. That's from the side of the potential energy, equal to 109.4 on the side of the kinetic energy plus the work done by friction. In other words, the heat loss. All right. So when you do this, we'll have WF is equal to the BF is equal to 1647.6 minus 109.4. All right. So this should give you about 1538.2 joules. So this is the work done by friction. This is the work done by friction. Now we are told that as this crate slides down the slope, the heat generated as a result, we can calculate for that from the equation Q is equal to mc delta T, where delta T is the change in temperature, and that is what we are looking for. Now we've already calculated Q, which is the heat generated or the work done by friction, as 1538.2, which is equal to the mass of the crate and its content is 35 times the specific heat capacity of the crate, which is given as 3.650 delta T. So we have delta T is equal to, if you calculate, that will give you 0.012 degrees Celsius. So that is the temperature change